Not to be. That is the question. What is that from? That phrase, to be or not to be? Do you know? You're getting your ELA lesson today. So your English teachers, you can let them know you did this in physics so you don't need to go to their classes anymore because we're tackling it here. Okay. Yeah, right. Okay. So to be or not to be, that is the question. What famous Shakespearean character said that? It's a Shakespearean character. Have you read Shakespeare at all? It is Hamlet. Very good. Ding, 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 ding. Morgan gets an A in her English class. Who's your English teacher? I will let Mr. McCutcheon know you knew the answer. The rest of you, you need to watch or read Hamlet. I suggest watching it. Reading a play, Shakespeare's all plays. I have a hard time when I read a play. In my head, I'm like, each character is a different voice. So I feel a little schizophrenic when I read a play, right? Because all these different voices are happening in my head at the same time. If you ever need to watch that one, have you watched it in English class?
We haven't done it in class, but I've seen like clips of it.
Okay, the one you want to watch, it is so good. So I'm a physics teacher. English was not my thing. It really was not my thing. When I took the AP Lit exam as a senior, I got a 2 on that test. That's not passing. That's like, I did not pass my college English classes, okay? Physics, math, no problem. English, not me. Because it's all lit. I'm not a literature person. I am a technical writing. I can do that. And actually, that's when I went to RPI. They're like, you don't have to take any English and test it out. I had to take a writing test. I could write technical things. So I passed. I didn't have. That's why one of the reasons I liked RPI. Because I didn't have to take any English while I was there. But the best version of that, if you can find the play that Mel Gibson starred in as Hamlet, it is so good. It is so good. Write that down. Mel Gibson, Hamlet. I'm sure you can find it on YouTube or Netflix or Amazon Prime or something. Maybe someday I'll show it to you. I'm not feeling like teaching. I'm tired from having whatever I have to have. We'll just put Hamlet on. It's not physics, but I have to find a physics one. Something physics related. Otherwise, I'm going to get my hand slapped teaching outside my content area. I'll switch with the English teacher for the day. The English teacher will come teach you physics, and I'll go teach English. I don't know that you really want that. Okay. Anyway, but that's an awesome version of that. And I think who played his mother in that one? I can see her face. Very, very, very famous American actress. Blonde. At least she used to be blonde. She's not anymore. She's much older now. It will come to me. I'm sure by the end of the period, I will be able to tell you who played his mom. It's a little. I'm not going to tell you. I will spoil it. You have to watch it. It's filled with. It's all like soap opera. Shakespeare wrote soap operas for that day. So you're all like, oh my God, can we just get to physics?
No, I like Shakespeare.
Okay. You're the only person in here apparently who likes Shakespeare. All right. So in our packet, I believe we left off on page 11. We got through all of page 10. At least my packet's all done. So because I was doing it up on the screen, I'm assuming that you have it also done. Yes. Page 10 is done. We're on page 11. All right. So let's just review because page 11 is a comparison to what we did on page 10. So let's just go back through what we did on page 10. We had this position time graph. Oh, I want to go through one other thing on this graph. Position is the variable X. Time is the variable T. Position is which variable in the experiment, dependent or independent? This is dependent because it's on the y-axis. We should know that. That's review from unit 1, but it could keep coming up. And time is therefore the what variable? Independent. Which I know I've had students ask me for before, how can time be the independent variable? That's the one that we're supposed to be changing as the experimenter. You can't physically change the time. It just automatically happens. Time goes on. So that's why it's considered to be the independent variable. Whenever you measure against time, that's usually the independent variable. But anyway, we talked about how these two cyclists are not starting at the same point. These are the starting points. So that is the initial position for bicyclist B. And that is the initial position for bicyclist A. The y-intercepts are those initial positions. So since they have different y-intercepts, they have different starting points. We then said here over at 7 seconds that cyclist A was ahead because when I look at that y coordinate, that is a more positive value. Remember, we talked about turning the graph like this. So this is our measuring tape. That's our 0 on the measuring tape. This is at a more positive position than that. We can see that visually when we turn the graph. Letter C, we said that cyclist A was traveling faster. And the whole reason that was, fast refers to speed. Speed is part of the slope. It's the steepness of the line. So since A is steeper, it's faster. D, are their velocities ever equal? The answer to that would be no, because in order for them to have equal velocities, they would have to have equal slopes. The slope of this line is never the same as the slope of that one. And letter E, what's happening when these two lines intersect here at 5 seconds? At 5 seconds, that just means that they've caught up to each other. They're now at the same position because they now have the same y coordinate on the graph. They're at the same position. All right, any questions on page 10? All right, then let's look at page 11. Now what we're going to do is look at the same two cyclists, but this is the graph of their motion now. This is a new graph that is produced for them. This is what we saw on the previous page. Okay. I want to know, how does the motion of cyclist A in this new graph compare to what we had over here in the previous graph? Anybody tell me? How does cyclist A in the new graph compare to the old one? Don't think too hard. How does A compare in both graphs? Miranda, what do you think? They are. They are the same. So cyclist A is doing the exact same thing they were doing before. So the graphs are the same. Cyclist A didn't change their motion at all. It starts with the same y-intercept and it has the same slope. So they're doing the same exact thing they were doing before. Okay, letter B. How does the motion of cyclist B in the new graph compare to what's here? Are these graphs the same? Oh, I just closed it too, didn't I? Hey, Braden. Uh-oh. What is that? No, you just hold on to that so that way if anybody asks why you're using the elevator, well, they might. A custodian might, especially the one that's right here. We have one, the next little hallway. There's an elevator for the next stairwell that goes upstairs. There is an elevator there. They use that. That's our freight elevator. So if you happen to use that one, they might ask you. Although they're going to look at your leg. And our custodians are intelligent enough to know that a boot on your foot, yeah, you probably can't do. So you don't need surgery, do you? Oh, good. Well, as I say, hey, we could be surgery buddies on Thursday. Anyway, let's go to letter B. How does the motion of cyclist B in this new graph is here compared to what we had here? Something is different about those lines. What's different? Liam? What do you mean it's decreasing? Use some terms that we were talking about in our notes the past day. Lucci? And how do you know that? So what type of slope is that? There you go. That's what we're looking for. This has a negative slope compared to the previous graph where B had a positive slope. So cyclist B is now moving left because its graph has a negative slope. Very good. I'm taking my time because we have 3 questions left to do this class period. So we might go back to Hamlet. Letter C. Which cyclist has the greater speed on the new graph? Liam? How do you know? Yep. So cyclist A, very good, is moving faster because cyclist A's line is steeper. I just remembered it's Glenn Close. I told you I would remember the name of the actress. Glenn Close played his mom in that. She doesn't live that far from here, you know. She lives down in Westchester County. I'll tell you how I know that in a little bit. Letter D, because we're going to have all this extra time. Letter D, describe what is happening at the intersection of lines A and B on the new graph. What's happening there? Caroline, can you tell me? Where these 2 lines intersect, what's going on? Yeah, that's right. So A and B are at the same position, and that's because they have the same y coordinates at that time. Letter E. Which cyclist is traveling a greater distance in the first 5 seconds? And how do we know? So first 5 seconds would be from here, 0 seconds to 5 seconds. Which one is traveling a bigger distance? Anson? How do you know? The slope doesn't tell me about distance. It tells me about speed. Which, okay, so but that's again not telling me about the distance. Yes, when you have a greater speed, you're going to move a greater distance. But what on the graph, there's something there that would actually give us the distance. All right, I'm going to, yeah.
So at the 5 second point, you can see by using the y-intercept, like the amount of change from where they start versus where they end.
Bingo. Okay, so this, if I come over, that is what I'm going to call their final position, XF. Cyclist A starts here. That is its initial position, XI for cyclist A. This is the initial position for cyclist B. Now, remember we talked about how we can turn this graph 90 degrees? Let's do that. And you can do that too, because you can turn your paper just as easily as I can. And this is our measuring tape out in the hallway. If somebody starts here and ends up here versus somebody starts here and ends here, who traveled a bigger distance? A. This from here to here, that would be the distance traveled by cyclist A. That space. And from here to here, I can't put it right here because I have all those labels. That would be the distance traveled by cyclist B. Can you see now that A has a bigger distance than B? You can visually see it. Now, on a graph, that's what we call the rise of the graph. That vertical distance is called the rise. You've heard in the slope formula, rise over run. Rise refers to the vertical height between those 2 points. So in this case, the distance is the rise on the graph or the fall. But we don't usually say fall. It's how much it goes up or how much it comes down is what we call the rise. So which one travels a greater distance? Cyclist A travels a greater distance. And we know that because A has a greater rise or difference in y coordinates. Does that make sense? Yeah? Okay. That's it. That's it. Your homework for tomorrow are the next 2 pages. This is page 12. This is page 13. I suspect you can do most of this without watching the video that I've posted, but there is a video that goes along with these 2 pages. Would you like me to show that to you in class now, so then you don't have to watch it later? I'm going to tell you now it's probably going to go too fast for you to get every answer, but you probably can get most of them. And then, because the questions go in order with the video, but the video moves. It doesn't give you a chance to stop it and write things down. So that's what I'm going to say. I'll start it, show it to you, you get down what you can, and then later on you can go back to the video, pause it, and so forth. And let me just explain before I do this how things are going to work tomorrow. Since tomorrow's the first day, I'm not here and Mr. Walter's taking over for me. So what he is going to do, this is what I've asked him to do. So I can't say this is what he's going to do, but this is what I've asked him to do. I have instructed him to come into class, connect his laptop to the projector, and open up our Google Classroom with tomorrow's post. So you will see the post on the screen like you do every day when you come in. You should be reading it. He'll probably read it over to you first. He's then going to start the video from the class a couple years ago, which starts by going over the homework. You should be prepared to come into class every day with the written assignment out on your desk at the start of class, because the video will always begin with me going over the assignment. And he is going to start it as quickly as he can at the beginning of the period, so that way there isn't any left over for you to watch that night. Right? And unfortunately, that's what would have to happen. If the video doesn't finish during the class time, you're going to have to watch the rest of it at night in addition to whatever written assignment. I apologize for that, but it's not like I'm here where I can then tailor what I do the next day based upon how far we got the previous day. It's all canned, right? So unfortunately, that's what we have to do to keep the pace. I don't anticipate it being a problem because by this point in the day, he's got the routine down. But tomorrow may be a little off just because it's his first time doing this with you guys. But he is an experienced substitute, but he knows that I usually do. Boom, 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 boom. Everything's go right in sequence. So just have this out on your desk. He's going to check that they're both done while you're checking your answers to try to save some time. And then you'll see right after I've gone over the 2 pages in the video, I say, okay, kids, you can use your homework to help you with the quiz. Take out your Chromebook and take the quiz. And you will see the kids on the video taking the quiz. And you'll see it count down because it shows. Okay, there was 18 kids in the class. Now 16 of them are done. There's 2 left. Oh, now they're all done. Okay, let's move on. So you should be getting your quiz done in the same amount of time that it took those kids that year. Maybe, maybe not. If not, he'll probably pause it. I don't know. We'll figure it out. And if you guys finish before that, he can fast forward to get things moving. You know what I mean? Okay. And then it will just go through the notes and the practice questions, just like I was here. So it should be pretty seamless. You're going to feel like I never left because you're going to see me every day. An older me. No, a younger me. You go, wow, she was so young and beautiful. What happened to her in those couple of years? A lot has happened in the past couple of years. But anyway. So let me get this back up. I am not going to record me playing the video for you.